Okay, so first of all, I would like to just make one comment. So today, the idea or the goal is for this to be somewhat of an interactive discussion. So feel free at any point to unmute yourself and share your thoughts or ask questions or bring examples. There will be some questions, no prizes, but definitely questions, and I will be looking for answers from you guys. And if you want to share your videos, there will be some exercises that the videos will be important. So if you need to, make your hair nicer right now, you can start working on that. But we will get to those parts a little later on. So and one last question that I have to ask: can everybody see my screen? Awesome, I see some nods. You can, whenever there are questions of like yes or no questions, you can either raise your hand to the video, to the camera, or Zoom has an interesting option to put a virtual thumbs up, so you can do that as well. There you go. Either way that works for you, or you can use the chat maybe. Again, up to you. So the main goal for today is to educate, entertain, and encourage you all to use critical curiosity, we call it, whenever you use or see visual data visualization. So we all learn very early on that not everything we read in the paper is true, and not everything we hear on the news is true. But unfortunately, we don't hear the same thing for graphs and charts and statistics, right? If something is backed up by statistical research, a lot of people are very comfortable assuming that everything they see is right. So today we're going to cover a few examples that tell a different story. And again, one more before we actually start with the presentation, I would like to introduce myself as well. So my name is Haim Shternshus, and I'm the Director of Data Analytics in a credit union here in Jacksonville. I like to think of it as the best credit union in North Florida, but I might be biased, who knows. I've been dealing with data pretty much throughout my career as an engineer and into the actual data profession. Data nerd, I really love big data and big tables that contain a lot of messy data and kind of finding the interesting insights in them and allowing people who actually do the work to base their work on better decisions based on reality, on data, and not on gut feels. So the discussion today is about data visualization, right? So what is data visualization? The simplest definition is that it's a graphical representation of information and data. So pretty much anything that brings numbers into some sort of graphical representation. So we have, the graphs that we all know, and charts and maps and schematics. These are all considered data visualization. And if you want to sound a little bit more knowledgeable or cool when you talk about data visualization, just say data viz, and people pretty much will assume that you know what you're talking about. So just some tip to keep in the back of your heads if you would like to. All right, and I would like to start with an exercise that I find very intuitive to understand and very powerful in allowing people understand better and grasp the power, how powerful data visualization is. So if you don't mind, for this exercise, all the people who are not sharing their face, if you are able to put a camera on, that will be good, because I would like here to see hands coming up. In a second here, you will see a table or an array of numbers and digits and characters. What I want you to do is to count or find out how many times the number 5 appears within that array. And it's not a trick question or anything. There's going to be a little timer underneath counting the time. The 5 in the timer is not considered one of the 5s that I would like you to find. So what you need to do is, again, find out how many 5s there are. And once you have an answer, just raise your hand, your real hand or your electronic hand, to let us know kind of how long it took for everybody to do that. All right, so here we go. All right. All right, so about 8 seconds, I saw the first hand going up. You think 6 seconds, Eyal? Okay, Eyal thinks he did it in 6 seconds and around that time. So 6 to 8 to 10 seconds.
I saw 6 5s.
Oh, okay. I get it. So Eyal got 6 5s within 8 seconds. At this point, I'm not going to tell you if it's right or wrong. The people who found more than 6 5s know that Eyal is wrong, but I'm not going to say it. What I'm going to do, that's right. What I'm going to do here is going to essentially give you the same task again, only this time I'm going to use and apply a data visualization filter on the same database. And do the same idea. Count the 5s and raise your hand when you think you have an answer. Yeah, that was a bit faster, right? So if you don't mind unmuting yourself and tell me, what do you think happened here? What did we prove here? What did we show? So basically, data visualization is a quick and easy way to find the important portions of the data out of the whole big data lake that we have around it, right? It helps us very intuitively make complex situation or complex databases into very simple insights. And maybe not so much in this case, but we can definitely use data visualization to identify trends and find outliers much quicker than we would have if we just had a big Excel table of numbers, for example.
But Haim, I think it also gives you the idea of maybe the other point that you will be making. I have to trust you that you highlighted all the 5s, right? I thought when I count now 7 5s, maybe there are 8 or 9 of them and you just didn't highlight them, and then I will believe that there are only 7, right?
Yeah, that's a great point.
Trust that visualization, but by doing that, you basically take some kind of responsibility to show us the correct information.
That's 100% right, and your point is super valid, and yeah, always question authority, right?
Well, the other point is that you are basically forcing the viewer to ignore all the other numbers and just concentrate on 5.
Right, because in this case,
you're guiding the narrative.
Sure. And that's something, again, that we need to keep in mind, that whenever we see a data visualization, there is likely a narrative behind it. In this case, the narrative was shared with you, right? I asked you how many times the number 5 appears in it. So in this case, it wasn't really, hiding other insights, but just focusing what we were trying to achieve. But you are 100% right. Yeah. Well, let's talk a little bit about the specifics of data visualization. And I'll go back to my early childhood when I was young and easily impressed. I thought that a 3D pie chart was the best thing ever. Okay, it had a 3D effect. It had angles. It was pretty. I think this was even before I started using Excel. There was some other software that I used. And whenever I was required to make any charts or data visualization, I didn't know the name back then, but whenever I needed to do that for some class, I usually used the 3D pie charts.
So are you suggesting it's not the best thing ever?
Well, That's a nice segue to the next slide, and the answer, yes, I think we are using pie charts way more than we should probably, and let's talk about that. All right, let's discuss pie chart. So pie charts it's within the data visualization community. It's a highly debatable discussion. There are a lot of people who feel very passionate about using or not using pie charts. There were a lot of research done, and let's discuss just a little bit of it. So let's say in this example, we have the sales volume of a store last week, broken down here by 5 salespeople. And we see the relative income of each of these salesperson. So when I show you this pie chart, how quickly and easily, for example, are you able to tell me who was the second best salesperson last week? So we can probably, you know, try and maybe figure and estimate. But let's say I'm adding 2 more weeks to the equation here, and I want to know who is the salesperson that improved the best that improved the most from week 1 to week 2 and to week 3. So for any of these questions, giving that data here, pie charts, and if you don't agree with me, please interfere and let me know. I think that pie charts in this case are probably a pretty bad tool, because I couldn't answer any of these questions right off the bat. As opposed to, let's say, another tool, bar charts. If I ask you any of these questions that I already asked, we'll be able to answer right away that Justin is probably the one that improved the best or the most from week 1 to week 2, right? We can see right away that Jana was the second best, or actually she's tied with Justin in the second week. But all of these questions of comparing salespeople to each other, we can do much quicker and more intuitive, even without any real data, right? There are no numbers here. We just see sizes and comparison.
What
Yes.
if you attach numbers to the pie chart?
Yeah, sure. Of course, there's way around it. You can do that. My argument will be, and maybe that's something that I didn't talk about when I introduced the topic. So data visualization, one of the underlying goals of data visualizations is to get the user to understand the data, or to get to the answer as quickly as possible. So yes, while I add numbers, definitely that will help, and the pie chart will be more useful than what it is right now. But if I compare it to the bars, where I can see that answer even without adding the numbers, then I would still argue that the bars are more intuitive and a better choice here. But yeah, definitely, if you want to use pie charts, you will have to bring the numbers in. And actually, that's a good, again, good segue to the next topic. Or the next example, back to that 9th grade pie chart. Let's say my boss came to me and said, you know, I really want that data represented nicely, and I really want it in a pie chart. Okay, so this is one example, one case that you probably have to use a pie chart when you were told that the end user wants a pie chart, right? So let's see how we can maximize the use of pie chart and optimize that data. So first of all, we get rid of the 3D because 3D introduce perspective into the view, which means that the slices that are closer to you appear bigger than the slices that are away from you, and it kind of puts things in uneven situation. Then once we bring it to 2D, we know that the angles are real. What we see kind of is what we get. And in this case, let's say that the data represents 100 cars that are parked in a specific parking lot. And my boss wants to know, which car or two brands of cars are the most common or the most popular in this parking lot. Okay, so we flattened the pie chart first of all. Now, remember earlier, one of the questions was who was the second best salesperson, or who is the fourth worst from the end, right? So whenever we have a question like this, and a lot of times we do have them, it makes sense to order the data from top to bottom. And here the cars originally were just randomly placed on the pie chart. So what we want to do, or what we can do, is make it such that just makes sense. So now if we want to find the fifth most common, we just need to count 5 slices down, and we don't have to compare all the sizes first. Now, there was another very famous research done on our brain, or the human brain, that claims that the human brain cannot really grasp more than 5 to 7 pieces of information at the same time. When translating it to this situation, it means that whenever you have a pie chart with more than 7 slices, you are incapable to grasp it all and take it all back in. So keeping in mind that our goal was to find what is the car that is most common or most popular, we know that we probably don't care about, you know, the Audis and the Buicks here, because there are very few of them. So what we can do to make the data a little simpler to grasp here is to reduce the number of slices. So in this case, I focused on the 4 most popular cars, and I grouped all the other cars into one category, called it Other. And like you suggested earlier, if we bring the numbers in, we definitely make it much easier to see the data come to life. One more thing we can do is bring the name, the titles of the category in as well, and then we can even get rid of that legend, kind of saving another second or 2 for our eyes, you know, to skip from the legend back to the pie chart and find the colors. And now also comes the question of what is it that we're looking for, right? Because we want to make everything as simple as possible. And again, if the question was, what is the car, what is the most popular car in this parking lot, we don't really care about all these different colors and actually these colors don't really have any meaning now, right? What does it mean that Jeep is yellow and Honda is gray? We can just gray them all with the borders that still signify the slices, and maybe color or highlight the Toyota because that was the car we were looking for. And we have a much simpler and cleaner and easier to read and understand data visualization that allows us to come to the answer much quicker. Any questions about that? Any comments or thoughts? If not, we'll continue with something that I find very peculiar. So some data makes sense to be put in a pie chart, but then I discovered this pie chart a few weeks ago, and that didn't make any sense to me. So what we have here is the relative annual cost between 1982 to 2011 of chestnuts, apparently. And for some reason, the creator of this visualization decided to put it in a pie chart. So if I'm asking you, in general, can you, are we looking at increased costs, or are costs, getting higher every single year? Were there any years where we had a dip in the cost? What is the year, with the highest cost of chestnuts? All of these answers can be probably achieved by using this pie chart, but they will require some work, right? So here I have I took another suggestion, and when I looked at it, first of all, since we started at 82 and moved from year to year, the phrase that came to my mind was timeline. And timeline has a line in it. So it made sense to put it in a line graph and not a pie chart. And you'd find that a line graph is very, very popular with any continuous property, such as time, right? When we have, for example, can you see my arrow here, my cursor? Yeah, okay. So we have, 1984, and then we have 1986. Now, in between, there will be 1985, right? But even in between there, we might have June of 1984. So there is some significance to the line here, right? These are not necessarily just individual points. So again, this is why we call it continuous. So this is where it might make sense to use this line. In answering the questions that I asked earlier, it's very easy to see that overall we see a trend that goes up, but we definitely had some, that's what we talked about earlier, the outliers. We can see that 2000 was a more costly year, and we can see that 2009 was a much cheaper year relative to the years before and after. And if we want to even take this representation or this data visualization and make it a little faster and easier to read, we can bring the numbers into the graph. And again, we save our eyes or our brains those couple of seconds of moving from the axis on the side and try to intersect the point. So again, much cleaner version that allows us to find the information that we're seeking much faster. And from here, as long as we're talking about line graphs, not all line graphs are so easy to understand. So I found this line graph that shows some sort of revenue for different European countries. And again, an opportunity to unmute yourself and tell me when you see this graph, what comes to your mind? And not necessarily from a data point of view, but from a visual representation point of view.
Spaghetti.
I think
Yeah.
USB cables disassembled.
Yeah.
The trajectory of the next hurricane. You just never know.
Wow. Yeah. That's yeah. I wish the hurricane models will be so close together, but yeah, that's a good point. Would you say that it's a good way of representing this data? If I wanted to know, to compare, for example, Germany to France in 2012, how quickly and easily will you be able to tell me which had better or higher revenue? So again, you probably can, but it might take a while. And a while, I don't mean hours. It will probably be a few seconds. But in a environment where videos of more than 30 seconds are considered too long to watch, every second counts. So data visualization, again, needs to be a tool to allow us to come to a conclusion as quickly as possible, right? Because time is money. So I'm arguing that unless you are a physics student and need to submit a lab report, you really don't have any good reason to highlight your grid in such a way. So the first thing that I do when I have to clean a table like that or a graph like that is get rid of that noise around the data and focus on the data itself. And here we go back to the point we made already twice, I think, throughout this presentation. And that was, what is the question? What do we want to achieve by this data visualization? So let's say the question was to show the progression of Italian revenue throughout these years compared to other countries, right? So like we did earlier with the pie chart, I can do the same thing here. I can highlight Italy, which is what we're interested in. It's very similarly to highlighting the fives in the first example we had. And this will allow us to right away see the Italian progression, and we can see, it moved kind of flat in the beginning, and then at the end from 2015 or so, the revenues went up a little faster from year to year. We can tell also how it's compared to other countries. And we can do the same thing with any other questions that we have for that data. For example, when we look at 2019, who are the countries with the most revenue and with the lowest revenue? So again, it's just a matter of knowing what we're looking for and using data visualization to highlight the specific question, to find the interesting insights. So again, here we can see that right away, very easy to find 2015, for example, as the year that these two countries intersected, right? While looking for the same information here, we might have had some harder time to do that. Now, without really realizing this, what we actually did here was we went through a process that allowed us to clean the graphs. And that process in the Dataviz jargon is called optimizing or maximizing the data to ink ratio. And data to ink ratio is just a way of saying that I would like every piece of ink, right? Every pixel of color on this graph at the end of the day to actually mean something. So it's a way of getting rid of all the information that is not useful for us, all right? So those grid lines or the legend, if we don't have to have it, we get rid of it. And the less information our eyes and brain have to digest, the better, easier, and faster we can understand what the graph wants to show us. So once we know a little bit about best practices of data visualization, let's move to some real world examples and see how we can either improve on them or see if we can identify sneaky ways for them to try and I don't want to use harsh words like lie, but maybe mislead or steer away from the truth. So the first example is this nice graph that shows us an annual progression of something. And we can see that, we moved from 2019 to 2020, probably the steepest out of all the other years that we have here. And if I'd ask you to kind of describe the rate of change here, again, without going into calculations or deep thoughts, you'd probably say, well, it's a pretty, flat advancement from year to year. But if I'm looking at this graph, what I see is we have a bunch of data that is capped at 14, right? The highest data point we have on this graph is 14, yet the x's go all the way up to 40. And I don't really have a good explanation of why that is. So if I don't know why it needs to go to 40, I would cut the x's at 15, which in this case is a little over the top, over the maximum value. And this gives you, even though the data is exactly the same data, the numbers are the same numbers, it gives you a different perspective of that data. All of a sudden, if I'm looking at it now, I'd say, oh, wow, there's a huge jump between 2019 and 2020, right? And this is the same information that we had earlier, but data visualization has a lot to do with your, with your psyche, with the psychology and how you perceive data when you first see it. So from here, we'll move on to the next example. Here we had an issue with the y-axis, with the vertical axis, and now I argue that we have something going on fishy with the x-axis, right, with the horizontal axis. So we're looking at this graph, and we see it seems like a performance comparison between two processors. And if I'm, again, not looking at the numbers right away, just looking at the color, I'd say, oh, wow, the blue processor is, more than twice as fast as the red one, right? But when you actually look at the numbers, you see that the X's start with 67.4 and goes to 69.2. Again, I don't have the actual data behind it, but I'm pretty sure that when I measure speed or performance for these processors, I can probably go as low as 0 to measure that. And this is a dirty trick that we see, unfortunately, we see a lot, where people want to artificially inflate a gap. So they just focus on that little gap at the end of the bar and ignore the fact that our real data started at 0, right? So if we plot it based on using the right scale, we all of a sudden see that the difference is not that great at all. We obviously still see that the blue is faster, but percentage-wise, we're now talking maybe 1 or 2 percentages, as opposed to earlier where my eye kind of thought that the blue was more than double.
I got an email. Alpana upgraded the password for your Apple ID ac@icloud.com has been successfully reset.
Yes. So I told you which one.
I'm sorry, was that a question? I didn't get that.
I think that's background noise.
Background noise. Rashna, if that was a question for me, I would love to hear it again. If not, yeah, if you can mute yourself, perfect. Okay, so we talked about that x-axis, right? The horizontal axis not showing the 0. Here we have a problem that is much more rare to see, but it's very interesting nevertheless. So again, looking at it from a just perspective or just estimating the sizes from a first glance, I would tell you that, and the graph here represent some election somewhere, and these are assumably 3 parties and how many votes they received, right? So I would say, all right, the red party obviously is the first place, and the blue party there got roughly half the votes, and then we have that gray party that got about half or 2/5 of the blue votes, right? Well, again, take a look at the numbers, and the gray party had 0 votes, right? So if it had 0 votes, why do we need to even have a graph? Why does it get a bar? If we plot that data on a real scale, 0 doesn't get any length. So now when I look at the graph, I say, all right, we have the red and the blue. The blue is roughly half of the red, and there's nothing with the gray, right? So this kind of comes to your question from the beginning. Do we trust the user, and is there any hidden agenda that they're trying to push? So maybe the hidden agenda earlier was, yeah, it was a 3-party race, where in actuality it was only a 2-party race. So that would be something again to look for, and look at all the x's and see if the numbers make sense, if they start at the beginning, if they start before the beginning, and where they end.
Yeah,
so
according for the first graph, you could these 2 parties could combine forces and actually get more than 30, right? This is what it would look visually.
Yeah, when was last time you saw 2 parties join together, though?
But it doesn't matter, because even if they did, it wouldn't. That's just...
Yeah, that's correct. So now we have another example, and I would like you to look at the 2 axes and tell me what do you think about this graph when you look at it? What are your thoughts?
There is no real timeline here, so it gives the illusion of time, but there is no such thing.
Right, it gives the illusion of
that sales is using all the travel expenses.
That's always the case, yeah. But yeah, you're absolutely right. We see some sort of a perception of progression, right? Where actually, what does it mean that we have a progression from the marketing department to the IT, right? If we're looking at this area right here, does this represent anything? You know, the data point between marketing and IT.
No, that should be represented, if nothing else, is in bars, not a.
I think a pie chart is still fine, but yeah, bar is good enough.
Yeah, and if you remember when we talked about the line earlier, we said that the best time to use it would be when we deal with continuous data. In this case, we are dealing with distinct and there's no continuation, right, between the department of this company. So it doesn't make any sense to draw that line. So like you said, we can do maybe pie chart, we can do these bar graphs. And then I have another question. Is there any particular reason to have, you know, the executives first and marketing second and IT third, or was it just an arbitrary decision? And as long as I don't have a reason to believe that there is a good reason to sort them the way they were, I would always try to sort them in some way that makes sense. So in this case, from highest user of the travel budget to the lowest. Might not make a big difference here when we talk about only 6 departments, but let's say we had 20 departments and we wanted to know which department or which were, you know, the top 4 departments to use the travel budget. It will be much, much easier to get that answer if we had them ordered from top to bottom.
Yeah, and if I can...
You notice how the finance department are able to conceal their expenses?
They just don't travel. They are kept in their office working, yeah.
They are more mindful of the costs, so they don't travel.
That's what they want you to think.
Yeah, some other things I'd want to see is number of employees per department, because there might be only 2 executives and 5,000 salespeople. Right. I'd also want to see the cost per trip,
right,
person. Then you see if you know, marketing spending, you know, however much, you know, per trip per person,
yeah.
Sales spending less, and kind of, you know, look at it more per person per trip as well.
Yeah, very true. And that again goes back to the question of what is the question, right? What are we trying to find? And if the question was what is the cost per person, then you're right. This graph or data will not give us the answer. Okay, so now we are all trained in looking for a horizontal axis and vertical axis, and I'm throwing you this chart here. And I'm going to introduce another issue that you will not be able to tell unless you're familiar with the data. So what we're looking at here is, you know, number of million of units sold from year to year. And we can definitely see that, you know, starting 2006-ish, we all of a sudden had a huge boom. And by 2014, we more than doubled, tripled, quadrupled our sales, right? Well, again, there's no way for you or for us to know that this is actually deceiving, because we are not aware of what happened before 93 or what happens after 2014, right? But luckily for us, I was able to find the original graph. And all of a sudden, when we have some historical perspective, we can see that 2014 might have been, you know, quadrupling 2002, but compared to the 70s and the 80s, this industry is in a huge problem, right? And whenever we see something like this, we call it in the Dataviz community, that's called cherry picking, right? I have all the data and I decide what portion of the data I want to show you to drive my narrative. In this case, it seems like the narrative was to show that, you know, we're getting better, and 2014 is a much better year than anything that's ever happened before. While the whole picture might draw a different conclusion. Okay, any questions before we move to the test?
So is there any kind of standardization or normalization done to the data before these graphs are produced so that, you know, we are looking at all of the data like pretty much from a real perspective, as opposed to there being biases or you know, ratios that we don't know of, but then they misrepresent in the graph?
So unfortunately, the answer is that we don't know, right? We either need to trust the person that created the graph, or we need to request the data, right? If you are the end customer and you receive a graph like this, I would expect you to say, all right, show me the actual data so I can tell if you cherry picked or if you did anything else that might have paint a different picture than reality. As far as normalization, they say that the biggest portion of work of any data analyst is in cleaning the data. I tend to agree with it, that is something that takes a lot of time. It's not really the scope of this talk here today. But yeah, there's definitely a lot of cleaning and treating and taking care of the data before it's ready to be presented in a graph. All right, now I promised you all an interactive portion of the talk here. So again, I encourage you to show your cameras again, or to share your screens, to show your faces and screens. And what I want you to do is look at this, obviously, pie chart, because we're talking about pizza, so they thought they were very clever. And this pie chart shows the times or the duration of the CEOs of Papa John's. Okay, my claim here is that each and every one of you can do a better job than this graph in showing and representing the same exact data in a better way, a way that will make it faster and easier to answer questions such as, who is the CEO that said the most on the CEO chair? Were there any CEOs that were working at the same time? Or any question about this data? I think you can do a better job. And I encourage you now, in the next 5 minutes or so, I'll keep quiet. And if you have pens and paper next to you, or pens and a piece of wall, or anything else that you would like to utilize, and at the end of these 5 minutes, you will have the option to share it. You definitely don't have to share anything with us, but I would love to see what you can come up with. So just take your time, and if you want to point your camera at your data visualization as you're working on it, you're more than welcome to do that as well. And Eyal, something for you to think about as we are getting closer to the end of the hour. We, from my end, we can stop here, or I have a few more slides. It's up to you how you want to control the time.
We actually allocated until 2:30, so we can continue.
Perfect. Okay. And you're done with your visualization, I see?
That's very sophisticated. So
Beautiful.
but there are several things in this pie chart, regardless of the fact that it's a pie chart. Even with the pie, they could have done a better job, right? There is the same guy that shows twice, and they didn't combine it together.
Okay. How did you choose to represent that guy?
I just counted the years, more or less, and I put a bar graph by the years of each
So
one.
you summed up how many years overall he was CEO. Okay.
And I put the initials of the person. I don't think my scale is so great, but more or less. There is also...
Sorry, go on, Yo.
Sorry?
No, continue, sorry.
There is also a sizable part of the pizza that is not accounted for at all, right? Oh, I see now. It is accounted for, but there is another piece on top of it. Okay. So the two big pieces should have been combined together. It really should have been just like you showed with the cars. There could have been one big piece of the main guy, and then all the rest of them will be whatever's left, like the tiny sliver that's left.
Well, the fact that they're using a pizza for a pizza company is clever. And I mean, I don't know that you could have used sticks, you know, like what do they call those things that they give you out with the pizza?
Bread sticks.
The fresh sticks, maybe. But so they're forced to use pies, but the way they use them, I agree with Al.
They could have stacked pizza pies on top of each other, like I've seen. Who should not be named that use toilet paper to do
little pizza, you know, little pies, you know, big, large, medium, you know, and small.
Nathan, were you trying to say something?
Yeah, I actually get it now with the co-CEOs, two pizza slices stacked on top of each other. Again, that shows an issue with the Dataviz that it confuses instead of illuminates.
So, what they were trying to do here is there was a year between 2010 and 2011 when they had two co-CEOs. That's what
I see now.
Yeah.
So, well, I think that they should have really ordered the people by the year, because I think if they are mentioning year, I'm giving it importance and precedence, because otherwise don't mention it.
Yeah. Did you create anything like that?
What's that? Sorry?
Did you create any visualization now that can show that?
No, I don't have one, but the verbal explanation would be that they could have sorted, the ideas are good. They could have sorted the CEOs by the year, because there are overlapping CEOs I can see here. Yeah. And that could be part of some information as well.
Yeah.
And I would say if they want to show this, it would be better to show them as two different charts if they cannot combine them together. Otherwise, showing two pieces of information in one is actually a bit, let's say, a bit too much information.
Okay.
Because firstly you have the length of period, and then secondly you have the years when they started and they finished, right? So they could have ordered it in the order of sizes like you showed in the previous charts. So then it was not necessary to show the periods in words as well. But if they really wanted to show from between which year to which year, then, you know, they could have done the same way, but maybe written it somewhere else, or at least ordered them in the year. It just feels that they have not done one part of the job well, and it just makes it a bit confusing.
Yeah, I agree.
Just now realize that there is a time element here. I didn't really understand it at first, that there is a timeline. Maybe a Gantt, something like a Gantt chart would be sort of more appropriate.
Oh, interesting that you say that, because I took a few minutes and tried to come up with a better way of my own. And this is what I did. So it puts everything you said kind of together, right? It shows you the timeline, like we said, linearly from 1990 to, you know, till to the future. And you can see not only how long each CEO was sitting, but also when, right? And you see here that Jude is intersecting as far as time goes with John Schnatter, and you can also see very easily that John Schnatter was a CEO actually 2 separate periods. Yeah, and I'm not saying that, you know, there is a right way of showing it and a wrong way to show it, but I think that for most data visualizations, there are better ways of showing. And again, this is just one thing that you can do. I'm sure there are many other ways that will be as productive and as efficient and better than the original pie chart. Even though, as you said, the pie chart using pizza was a very clever and cute idea. And I think that's what they were going for. So that was, you know, more towards the realm of infographics versus actually communicating data in an accurate way.
I think you have it on the nail there, because I feel that they were so drawn into the idea of the pie chart that they've forgotten that they are loading it up with more information, but also not explaining the information as clearly as the one you're showing us just now.
Right.
Where you can see the periods, and you can see the overlaps, and then you can also see the transitions, and you can also see who these people were as well, because from the pie chart, you can't really see that, like we missed out the information that John had actually 2 different periods of CEOship, and there was a small gap in between.
And it was much cheaper to produce because I didn't use any Adobe software here, and I didn't even have to spend money on the pizza. I just
exactly, you saved on the dough and the cheese,
yeah,
and the sauce.
Yeah. So moving to the next kind of portion of discussion is, we talked about how presentations can be, or data visualization can be deceiving a lot of times because of you know, the person kind of didn't know better. But like we saw in the cherry picking example, and like we're gonna see now, there are unfortunately some cases where people just purposely deceiving. And to introduce that topic, I would like to ask you if anybody here knows who Rebecca Jones is or what's her story. No idea. Take a look at the...
She was fired.
Yes,
The truth about the pandemic, the numbers in...
yes. So Rebecca Jones, as the screen behind her suggests, was a data analyst working for the Department of Health in Florida. And one of her tasks was to map the coronavirus progression within the state. And in fact, she did such a good job that somebody within, I'm not gonna try and really stay out of politics, but somebody didn't like the way reality was perceived, and she was let go. Okay, well, a week after she was let go, the department came up with this graph, right? So this is what happens when you let go of your data analysts. And we have a graph here that just, I guess the negative space is what the numbers represent here. Because when I took the numbers and plotted them, this is what I got, right? Which again, it's kind of the negative space that they used. So just because something is being used on a expensive tool and shown on TV, it doesn't make it right. Okay, so be skeptical and always question. And now, if you would like to keep your microphones on and unmute, I'm going to show just a bunch of different graphs, and I would like to hear your opinions about them. So what do the sizes of the circles represent here, right? When
Nothing.
I think there is a bias that they want to project. This is one view I'm getting.
Okay.
They want to make it look like the yes is a good thing, even though it's a lower number, and that's where they want their attention to go to, and to ignore that no, which is in this perception maybe a a bad representation, but for people to not remember it in that fashion.
Yeah, yeah. I don't know. I don't have a good answer for that, but yeah, I like the discussion. Let's look at this guy.
Ooh.
So I don't think they're deceiving. I don't think they're lying. But I think that this is a very, very poor example of data visualization. In my mind, it doesn't make the data any easier to grasp. Even though it might be easier than the way the data was arranged in the beginning, I don't know that. But just, again, think about your end user whenever you create a data visualization. Try to help them, try to make their lives easier.
Well, it certainly doesn't help make a really complicated situation any easier to understand.
Yeah, yeah.
All it illustrates is that it's really, really complicated.
Yeah, and maybe that's what they wanted to do, who knows? So here's another interesting one. And at this point, really it doesn't matter what the topics are, just the tools they used are kind of questionable. When you use a pyramid, what portion of the pyramid represents that 73.8 percentage? Is it the height? Is it the face area? Is it the volume? I don't know. If I were erasing this number, okay, just show you the colors, what would have been your guess for the number that went to this brown section? Would it be around 73, 74%, or would it be higher?
No, it's much higher than that because you're looking at volume.
I think so too. Yeah. And then to add to the confusion, right next to it, all of a sudden you have the same graphical representation showing something completely else. Now we're looking at number of servings. So again, how is this 11 and this is 9? I'm not sure. I really don't know. So again, no big insights out of these slides, just a whole bunch of question marks and confusion.
Yeah, and the title says, why does a salad cost more than a Big Mac? So I would expect to see dollar signs and cost somewhere.
Well,
yeah.
The answer is obviously 42, but yeah, I have no idea.
So it's not clear. It's not clear whether it's misinformation or it's trying to hide something or it's just mistakes and oversight.
Yeah.
So it could be so many things, right? Because it's a benefit of doubt kind of a situation.
Yeah.
It doesn't help that the colors are in a totally different order in the left pyramid compared to the right pyramid.
I took statistics a long time ago, and I had a real great teacher, I think, is the reason I enjoy math. But he had a saying, and I'm pretty sure it wasn't his, that says if you torture data long enough, it will confess to anything.
There you go.
And basically, this is what we see, you know.
And here's another cool one to think about. We all know the concept of word clouds, where the word that is the largest is the word that shows up the most times in a certain text. But as much as I try to understand what this represents, I just couldn't. So I would love to hear your insights. If you have any idea what these numbers represent and why some numbers are bigger than others, you know,
and why are there guns in there? What are
the
guns doing exactly?
Yeah, I don't know. So this is really a big question mark. And I guess if you're taking one thing out of this talk today, is really don't make your data visualizations look like any of these examples. So I think from Eyal, from my end, I'm done with that quick and short introduction to bad data visualizations. I have one more slide that I will leave for you guys as an extracurricular, extra credit activity. If you can figure out the answer to that, feel free to email it to me later, or you can find me on LinkedIn. Believe it or not, I'm the only Haim Shternshus on LinkedIn. So you can very easily find me and let me know if you have any questions, if there's anything I can help you in the future. And if you can come up with the answer to this question, I would really, really love to hear it.